Welcome to Math Simplified for You. And my name is C.A. Ramakrishnan. And today I'm going to talk about similarity in totality. Yeah, not just restricting ourselves to triangles only. So let's imagine that you have some A4 size papers with you and you decide to stack them up one above the other. When you stack them up, you actually see that the sides have become very smooth. Although they are different layers of paper, but still the sides have become smooth. Why? That's because these A4 size papers were of same shape. Of course, they were of same shape because they are rectangle and also same size. Yes. What else you see? Each corner is 90 degree, which means they are equiangular. This is a classic example of congruent figures. When two figures are congruent, they will be of same shape, same size, and the angles will also be equal. That means they are identical to each other, which means if I take one figure and superimpose on the other, they will be absolutely matching side to side, corner to corner, angle to angle, just the way we had in that A4 size paper. Then what is similar figures? Imagine, in your school, in your classroom, you are sitting on a rectangular bench, keeping your rectangular book and rectangular copy on a rectangular desk, looking at the rectangular board, wondering what the teacher is writing, and also looking through that rectangular window when you are bored, and often thinking of escaping through that rectangular door. So here too, everything I spoke about are rectangular. But the question is, were they of same size? Of course not. You can very well understand that the size of the copy or the book or the blackboard or the window or the door, they are different. Although each one of them is a rectangle, but they are of different size, unlike that A4 size paper that we had stacked. So this is an example of similar figures. So what are similar figures? They are of same shape, but different size. Yeah, the size of the board is bigger than the size of the book, although both of them are rectangular in shape. And also they are equiangular. Of course they are. The corners of that bench or desk or copy or book or the whiteboard or the window or door, the corners are 90 degree. So we can claim they are equiangular. So to conclude, similar figures are nothing but same shape, different size and equiangular, just like this. Yes. Now we are going to talk about triangles. Now here we see, of course, triangle ABC is smaller than triangle PQR. So very well you can understand that these two are not congruent figures. They are of same shape. Of course, both of them are triangles, but they are of different size. Also, we need to understand that they are equiangular. What do I mean? I mean angle B is equals to angle Q, angle C will be equals to angle R, angle A will be equals to angle P. Okay, just for the sake of convenience, we have taken like this. Okay, now these are corresponding angles. They have to be equal. That's why these two triangles are similar triangles having same shape, different size, and equiangular. Yeah. Now, if the angles are equal, what do you want to say about the sides? Sides are definitely not equal, that you can very well conclude here. But there has to be some relationship between the sides also. Yeah, there is. The sides are proportional. The word proportional should ring the bell. That means I'm going to take you to a chapter called Ratio and Proportion. What is the meaning of proportion? Proportion involved comparison of two ratios. A by B equals to C by D. Remember? That's exactly what we are going to do here. The sides are proportional, the angles are equal. But how do I conclude which sides are proportional? I cannot arbitrarily take any side I feel like. No. There are some conditions to it. What is the condition? Let's see. From this triangle, we can understand that angle A equals to angle P, the one on the top. So which is the side opposite to angle A? If I make an arrow, BC. So BC by, I said P, opposite to P, I have what? QR. So BC by QR. Again, I'm going to write angle B equals to angle Q. Opposite to angle B, I have the side AC. And opposite to Q, I have PR. And what else? Angle C equals to angle R. That means opposite to angle C, I have AB. And opposite to angle R, I have what? PQ. So from these three, actually, I can conclude that BC by QR equals to AC by PR equals to AB by PQ. This is how we conclude the proportional sides from the equal angles. That means the sides opposite of equal angles are proportional in similarity. Now, that means we learned how to identify the proportional sides using equal angles. Okay, let me tell you where you people go wrong. Not maintaining the sequence. What do I mean? If you look at the numerator of this proportion, throughout I have maintained the sides of triangle ABC. And in the denominator, I have maintained the sides of triangle PQR. If you have to interchange, you will have to interchange all the three sets. I mean, something to do with invertendo. You cannot have this side by this side is equal to this side by this side. No, you will have to maintain the sequence. Okay? And one more mistake I will talk about a bit later. Now, we have identified the proportional sides with the help of equal angles. Now, what about the converse of it? What if you have been given BC by QR equals to AC by PR equals to AB by PQ? What about this? Now, how do I identify which angles are equal? Yes, very simple. Look out for the missing vertex. What do I mean? We know very well we are only dealing with two triangles here, triangle ABC and PQR. So which vertex is missing here? Of course, the vertex A. You have BC, A is missing. What about this one? QR, what is missing? Angle P. Okay, let's see. AC is here. What is opposite to AC? I mean, which vertex is missing? Angle B. And opposite to PR or the missing vertex is angle Q. Again, the missing vertex is angle C and the missing vertex here is angle R. Now let's check if we are correct. Angle P equals to angle A. Lovely. Angle B equals to angle Q. Angle C equals to angle R. So you learned how to identify the equal angles using the proportional sides. That means what will you do? You will just look for the missing vertex. That's it. So now today we learned how to go from side to angle and angle to side. There is one more condition apart from these two, and that is side angle side. Now, as you can see by the name that angle is between both the sides. Okay, this is not any randomly arranged thing. There is a reason why it is SAS. The angle must be included angle. Included. Just like we had in congruency. That means what? The angle should fall between both the proportional sides. Let me give you an example. Let us stick to the same example here, ABC and PQR. Okay? Now imagine I know AB by PQ, AB by PQ. Well, this is a way to represent proportionality, okay? I'm not using a straight line, there is a curve, okay? And then I'll make a double curve here to represent BC by QR. So in between these two proportional sides, which angle is sandwiched? Of course, angle B and angle Q. Angle B equals to angle Q. This is the required information you need actually to show side angle side. Any other angle will not work. The angle must fall between two known proportional sides. Okay? So now we have learned how to change from side to angle to side, and we are clear about SAS as well. Okay? So these are actually the conditions of similarity. I did not do any sum today because I found that most of you have problems in understanding the concepts of similarity. So today I thought just to explain this concept. Now I'm going to talk about another place where you all make a mistake other than maintaining this order. What is that? Say I write triangle ABC. Similar. Then triangle, I should fill in the blanks. There is a way to write, that's very important. Angle A is corresponding to which angle of the other triangle? Angle P. Angle B is equal to which angle? Q. Angle C is equals to which angle? R. You will have to maintain the sequence. Any other sequence is wrong. Yes. This is very important, or else what will happen? Imagine, just with the help of this information given to you, you could comfortably conclude that A equals to P, B equals to Q, C equals to R, helping you to identify the proportional sides also. But imagine your friend gives you something like this. Triangle ABC randomly writes, say, triangle QRP, something like this. Now what happens? What will you infer from this information? Angle A equals to angle Q. Angle A equals to angle Q. Is it correct? No. Angle B equals to angle R. B equals to R. No. And C equals to P. No. That's wrong. Got it? These are the two mistakes that you people make in the answer script. Thank you very much. And my name is C. Ramakrishnan and you are watching Math Simplified for You.